All right, here we've got the exponential growth and decay word problems activity. We've worked on this two different times, and these are a lot of the word problems that are going to show up very similar things on the test. It's important to note that we're using our formula throughout here, our exponential growth, the beginning amount, the multiplier raised to the x. And so when I look at this here, I can see that the number of bees is increasing over time. And in fact, it is starting out at 500, and every time it's multiplying by 2. There's twice as many bees for every point that you move to the right. And so that's all you needed to do for this first one here is just getting that it's starting with 500 and it is doubling every time. It's not linear. Then there's some practice here converting between percents and decimals. Many people just, all you got to do is we got to read this right here. This tells you exactly what to do. So if we start with a percent, we divide by 100. That's how we move to the left. Or we move the decimal place 2 spots to the left. And so we can just go through these here. Moving the decimal place, it was 85.0, so now it's 0.85. Then 0.60, or you can write 0.6. Now, don't write 0.3. A lot of people wrote 0.3, but that would mean 30%. So 3% needs to be 10 times smaller than 30%. So you put a 0 in front of it to make the value even smaller. Same idea here. I saw a lot of people writing 0.725. That would be 72.5%. So we put a 0 here to make it smaller. Here we have 0.158 because I moved the decimal twice. Here I move the decimal twice, and if there's no space left over, I put a 0 in there. So for example, on this last one here, I move the decimal twice to the left, and the first time I move it, there's right there the 6, and then I have to put a placeholder 0 in front of it to make it work in there. And so I'm going to pause for a second. All right, moving along here to the next slide. This is just the same thing backwards. So now we start with the decimal and we move to the right. So we're going to move our decimal point 2 spaces to the right. So 0.95 is 95%. 0.2, move it 2 spaces over, you get 20%. 2 spaces over, here you get 7%. Here you get 4.5%. I'm just moving the decimal point 2 spots to the right, sticking a percent symbol on the end. The last one is bigger than 1, so it gets bigger than 100%. It's important to be able to do that because of this idea right here that when you have exponential growth, you're taking your percent R, making it into a decimal, and then adding it to the number 1. Similar sort of idea on exponential decay. It's just that instead of adding it to 1, you subtract it from 1. So here's an example where we have 150,000 people increasing by 8% each year. So I can write 150,000 people, 1 plus 0.08 raised to the t. Because it's increasing, so it has to be bigger than 1, and it's increasing by 8%. So I moved the decimal place twice and I added it to 1. You can simplify that, 150,000 times 1.08, because adding 1 plus 0.08 will work out to be 1.08. The last one here, raise it to the 5th power because it asks me to predict what's happening in the 5th year. All right. Exponential decay is the same idea, but instead of plus r, you're doing minus r. So right here, if we have a popular city, 250,000 people, and it's decreasing by 3.5%, I can write that as y equals 250,000 and 1 minus 0.035. I wrote it as a decimal. You want to raise that to the t power. Simplifying that would be y equals 250,000 times, if you lose 3.5%, that means you have 96.5% remaining. Or you can use a calculator and just write 1 minus 0.035, like I have right there. Or think about it in terms of 100 minus 3.5, 96.5. And so I take that, I write it down here. This last question asks me about 7 years from now, and turns out there'd be 194,000 people in there. After that, here we have just a lot more practice problems of exponential growth and exponential decay. I'll just do a couple of these multiple choice ones to hopefully you get the idea. So we had in the year 2016, we started out with 195,000. So that's going to be one of my B values. So I already can eliminate this. Then each year has increased. So I need a number that's bigger than 1. So I know it can't be that. By about 3.25. So if I move the decimal, I get 0.0325. And I add that to 1. So it can't be this one. This one doesn't have a 0. It's got to be answer choice 3 right here. That's the correct value. Let's look here. One last one. Recommended dose is 400. Decreases by 29.5%. So I know it can't be this choice because that doesn't start with 400. It's got to be either A, the first choice, the second choice, or the third choice. It can't be the first choice because that's got a multiplier that's bigger than 1. So now it's down to just the third or the fourth choices. I'm going to change my percent into a decimal, 0.295, and I'm going to subtract that decimal from 1, and that leaves me with 0.705. That is this fourth answer choice right there. So obviously there's 23 slides. If there are any other slides on this activity that are hard, please ask me. If there's something I said in the video that's confusing, please comment or ask me, and I will answer those questions. But it's important that you're practicing and using all the resources to get ready for the assessment. Thanks for watching.